Okay, hey, hello everyone. My name is Jesus Najera or Set Zeus on any of my digital handles, and today I'm here to talk to you guys about script. Uh, Honestly, super happy to see that this is a follow-up to Kenny's presentation on parsing Bitcoin transactions because that's a really great intro into what we're going to be covering here. And so script is the programming language that's actually within Bitcoin and that's within Bitcoin transactions. And so today we're going to be talking about them from beginning and then showing you guys how, how you can use a script sandbox and how everything operates from beginning to end. So first off, what is script? Why learn script? Real simple. Script is the actual instructions packaged within transactions that moves Bitcoin around. So more accurately, what script does is it passes the permission from UTXO from one public key to another. And it does this by using two different scripts that are concatenated together. And then the node comes through and verifies that if you execute them one after the other, they leave you with a certain value within a stack. And so most people's introduction to script is going to be when they look at an input or an output of a transaction, and they realize that an input and output both have script within. We have script sig usually in the inputs, and we have script pub key in the outputs. And script sigs are what, script sig is what unlocks an output. So script within Bitcoin, everything is going right down to the basics. Script is written as an array of bytes. And in this array of bytes, everything is either data or an opcode. And so opcodes are functions, commands, and operations as you expect. And data is obviously something like pub keys or signatures or anything that you need to push to the stack, such as, again, anything that an inscription, or if you want to add anything additional to a script. And so opcodes have a bunch of different, 5 different categories. And purposefully, the script language within Bitcoin is very, very, very limited. So there aren't a lot of different functions. However, script has a lot of syntax that is unconventional and so confuses people up, and rightly so. So starting with the opcodes, these are the 5 categories of functions that you can expect to see within script. And here we're going to see a few of the most common ones, or a few that you might be familiar with or might make sense off the bat. When it comes to the cryptography ones, obviously checksig is usually the last and the most important op when you want to confirm a transaction. We have the usual conditionals within flow, so your ifs, your ands, your ors, your else, etc. You have really simple math operations. And when I mean really simple, I mean to the fact that, kind of controversially, op multiply is not here, but op add and add subtract are. We have the push operations, which, as you'll see before, whenever you want to push data to the stack, you first need to tell the stack the size of the data you're going to push. And then last but not least, we have actual stack opcodes, right? And so these operations aren't limited to Bitcoin, but they're limited to the stack data structure, which you're going to understand a lot more about in the next couple of slides. Cool. The basics of a stack. And again, super apologize for this. I have no idea if this is going to happen. A stack is a data structure that follows a last in, first out life cycle. And what that means is that data and opcodes are pushed into the stack and consumed one at a time. And so sometimes, some operations will be done on items within the stack. So if we do like op duplicate, obviously we'll have one item in the stack, op dupe, it'll duplicate it and then push another item to the stack. And again, usually the data that is pushed is public keys, signatures, items that you would see in a transaction. So here's a really simple AKA script that has only 2 items, but technically only 1 item of relevance. And that is, if you look above, you see 020 and then 0031 DEE, et cetera, et cetera. The opcode on the left tells us how many bytes we're going to push. And again, one thing to remember about script is it's an array of bytes, which means everything is formatted in hexadecimals. So when we see bytes to push here, it says 20, but again, this isn't hex, so this means 32. So this means that we're about to push 32 bytes of data worth to the stack. Next, we see what actual data is being pushed. And yeah, and again, it's written in array of bytes. And above, we can see that whenever we want to push anything to the stack, we first need to tell the stack the size of it. Cool. So let's go through a very, very simple example here. And let's go through this script at the very top. So we have 1 byte. Well, again, we don't know how many bytes are there in this array, right? That's the complicated part of parsing through a script, is you don't know where each item starts and stops. So you have to go through one at a time. So we see this array of bytes. Okay, cool. Let's start with the very first one. Again, when parsing a script, and sorry, when using script and you want to push something through the stack, you have to tell it the size. And so right here, we can see that the first item, 01, if there were data being pushed to the stack, it would be invalid. So we can correctly infer that this is actually an op-size data. So this data, so this opcode is saying, hey, this is going to push 1 byte to the stack. Okay. And then also gives us a direction in how many items we need to continue moving towards. Because now we know we're going to push 1 data, we're going to push 1 byte. And so now we can move on to the next item. And so here we see 01 is now highlighted. And so now we're parsing through this, and you can see at the stack at the bottom here, I'm not sure if you can see very well, but in this first slide, we had op push 1, because again, we're going to push 1 byte. And then the second slide, the data that we're pushing, which is again, the number 1. After we push the number 1, again, we can infer that the next byte is either going to be, we can infer that the next byte is either going to be an opcode that operates on within what's in the stack, or it's going to be an opcode that defines the length of the next item we're going to push to the stack. Again, well, you don't know, but once you study these opcodes enough, you'll know that 02, or most of the numbers up to 0x76, are all opcodes that push data. So I know, okay, 02, cool. We're now looking at another opcode that prepends a data push, and we know it's going to be 2 bytes. Cool. And so now what are we going to push? Well, we know that we need to search for 2 bytes now instead of 1. So 03, then E8. So here are our 2 bytes. And we now know that we're going to push these 2 bytes to the stack. These 2 bytes, 03E8, actually make up the integer 1000. And so we're going to push 1000 to the stack. And so if you look at this image, we now have 1 and 1000. And now this very last opcode that we haven't consumed, because again, we now went through 03E8, we have 93 left. 93, and again, I think it's any opcode past 0x76 is now an operational opcode. We know 93 is an operational opcode. We look it up on a website or whatever, and we see that it's actually op-add. So now what op-add does, as you would assume, op-add consumes 2 items in the stack and then returns 1 item. And so here, again, it took in 1 and 1000 and it returned with 1001. And so ultimately, this array of bytes here represented a script, and that script allowed us to add the numbers 1 and 1000. And below it, again, you can track how this stack dealt with this. And so, of course, this is all cool to see it one step at a time, but we do have tools for this now. So I'm excited to show you guys what this looks like on BitScript. So let's go ahead and open this up. And we can open up the script sandbox, and we're actually going to go ahead and do what we were just doing. So let's say we wanted to add two numbers. Sorry, I'm going to try one. And then again, notice that the IDE actually injected I'll push one, because again, if we wanted to add one to the stack, we first need to tell the stack, hey, what is the length of the data we're about to receive? Next, we type in 1000. And we can see the IDE updates with, again, I'll push two, because we're now pushing 2 bytes to the stack. And then last but not least, we can type in op add. And if I'm going to put this to slow, and if we reset it and run it from the beginning, we can see each step happening one at a time. So we're pushing number 1 to the stack. We're now reading I'll push 2. We're now pushing 2 bytes worth of data to the stack, the number 1000. And now we're adding those two numbers with op add. Cool. And so just to give you guys another example here, I'm going to go ahead and go through another example, and we'll probably just end it there. But to look at some more operational opcodes, okay, cool. Let's go ahead and see what happens when we use op depth, op dupe, and op size. And so I'm actually going to pause this. And so we're going to go through it one step at a time. So again, I'll push 1. We know we're going to push 1 byte of data to the stack. The number 1, okay, cool. We're going to push the number 1 to the stack. Op depth. So op depth is one of the operational opcodes. And this is specifically in the stack category, because this operation exists within the stack structure in I would assume any programming language. But op depth puts the number of stack items in the stack. So obviously, if we have 2 items in the stack, op depth would return the number 2. If we had 3, it would return number 3, etc. Obviously, op duplicate, which op duplicate you might see in functions. And then last but not least, op size, which pushes the string length of the top element to the stack. And so now if we go ahead and run this one at a time, I might have to refresh this because I paused it. Okay, cool. Yeah, we're going to push the number 1 to the stack. Then we're going to push the depth of the stack, which at that point it's 1. Then we're going to duplicate the top item of the stack, which is obviously 1. And then we're going to push the string length of the top element, which again is 1. And so hopefully this gives you guys some illustration of how script works. And again, just to give some final structure, this script itself, if you were to see it, written out, it would be something like, oh, wow, sorry. Well, that disappeared, but it would show you, it would be 0x0101747682 all together as a single array. Because again, script is written in an array of bytes. And when a node reads a transaction, it reads the SIG script, which is meant to unlock, and it reads the pub key script, which is meant to lock, and it executes both of these together. And in fact, if I do have one more, okay, I don't have an example to it, but I guess I'll just end on a hashing function. Yeah, I want to show an example of what it would look like with a transaction going through there. But Yeah, we don't have that example at the moment. So I'm going to show one more equal and equal verify. And so this was, again, both equal and equal verify are common opcodes that you'll see used when confirming transactions. And both of them actually mean different things. And if you see the instructions, it means you see it at the top. But just to go through it, again, this is sort of how a stack would actually confirm or reject that a transaction is doing what it's supposed to do. Obviously, instead of checking whether it's one, etc., it checks pub key and it checks a signature and it checks and it returns the Boolean of that. And if the value is one at the very end and there's a single item worth on the stack, it's a valid Bitcoin transaction. If it doesn't, it's not a valid Bitcoin transaction and it's rejected early on. And so hopefully this gives you guys somewhat of a clear image into what's going on in the script side of things. And of course, if you have any questions about script or you're just generally curious to learn more about it, feel free to reach out to me. Again, my name is Seth Zeus. Thank you for having me. And I'm happy to share this. I'm happy to share the presentation as well if anyone wants to reach out to me afterwards.